Good afternoon, sir. Hello. Hello. Sorry. Just 1 second, sir. Just 1 second. Right, sir. Now you can do it.
Yeah, it's, yeah, it's all good now. I think you can go to your setting and if you do it, but if you are, I mean,
I need to only click one button, but that button should be visible. So today it was not visible.
okay.
Now everybody can unmute and talk.
Because in case if you are not here, we won't be able to run the session.
No, sir. I'll be there.
Yeah.
I'll even if I go, I'll make arrangements, and if anything is there, I'll get the information, sir. But as such,
Okay.
my plan is to be there throughout the session. So no issues.
Okay. So Lukesh has already completed PhD or he's doing masters or
No, he's under me, sir. He's working as a PhD scholar.
PhD.
We have a publication also, sir. If you
Yeah,
remember.
yeah, that's why I remember. So when he's expecting to finish or
Let's see this year, sir. I think so.
this year. Okay.
Bunch. Sir, as soon as you start, I'll just leave for 5 to 10 minutes, and then again I'll rejoin.
No, that's no problem. I mean, you can leave now. I mean, if you want. So we have got how many now? We have got 13.
I'll do one thing, sir. I'll again.
13.
We have 13, sir. 13 participants are there.
Maybe wait another few minutes, right? Or
So it's
because that's
1 o'clock. Now it is 1 o'clock, so we can wait for 2-3 minutes and then we can start.
yeah, because it takes like 4 or 5 minutes to join. So yeah.
Right. And actually, the thing is like there are many faculties, so maybe their lunch break will start at 1 o'clock exactly. So it may take 2-3 minutes for them to join. There are some students also who are there, so they may be also joining a little late because their classes will end at 1 o'clock.
Okay. I'll wait 5 minutes.
Yes, sir. Yes.
Hi, Dr. Sandeep. How are you?
Hello, Professor. Yeah, I'm good.
Um, so, which state of India you are from?
In Uttar Pradesh, in the North India, near
Uttar
to Agra.
Pradesh. Okay, okay. Yeah, I have been to Agra. I think 2 times. Yes, I was there.
Uh-huh. In Agra or Delhi?
Uh, in Delhi as well as I visited Agra as well.
Uh-huh. But now I'm teaching in Jaipur. I'm living in Jaipur.
Yeah, yeah. Okay. So
Living-
you teach in Jaipur, not NIT Warangal.
No, no.
Oh, I thought you are in NIT Warangal. Sorry. Okay.
Yeah, yeah. Somebody. Okay, maybe Altaf have given to my VC. Maybe you. Maybe meeting. So he forward to our entire faculty if somebody is interested in Jaipur.
Oh, yeah, yeah, yeah.
Sir, which college are you from?
JK Lakshmipati University.
Uh-huh. Maybe I only sent you a mail.
To me, my professor maybe. So then he circulated. Then I contact to you.
Okay, okay, okay.
But I visited, I mean, your NIT with, Professor uh, Professor Mishra from NIT IIT Delhi.
Actually, I spent 10 years in Europe
So
after my
you might not know
India.
him.
I am from Aligarh Muslim University. I did my MSc, and then from IIT Madras I did MTech in scientific computing,
Oh,
and then
oh.
I went to Europe.
No, I
I
actually
did.
went there with Sukumar Mishra. He's in IIT Delhi.
So I don't have that much knowledge in India, but because I just arrived from Sweden last year.
Oh, okay, okay, okay.
In this corona, so I don't have that much contact. So slowly, I think this networking will increase. That's why this GIAN is there to
So do
have
you know
some
anyone? Do you know anyone in Australia?
uh, yeah, I was working with one, two people in organic electronics in polymer.
Organic electronics. Okay.
Yes. So I know I have some work, I have done work.
Yeah. Okay.
So, so I did this fuel cell work also, but with polymer, conducting polymer, we are looking for as a fuel cell. Yeah, but
Oh, okay.
for organ because this is was in Sweden organic electronics lab. I was working in Stockholm. So
Yeah,
we
in
are
fuel
focused.
cell, I mean, we just recently started, but our work is more like the operation planning and
Uh-huh.
analyzing the grid impact, that side.
Yeah. It's a macro side or maybe a big
Yeah.
scale.
Yeah.
Yeah, but yesterday lecture was nice because we got some idea that okay, this decade is devoted to the battery technology or electric vehicle. But the whole world is, as you told, the whole world is looking for electrification of the
That's
vehicle.
right.
As you told you, at 2030, at least 50% people want their vehicle to be electric. And then this is billions of vehicle is there. That means this is a huge project, and all the world is focusing in this direction. So
That's
there's a
right.
lot of hope in this sector. Means
Yeah.
there's a lot of opportunity will come in this sector.
Yeah, it would be like, huge new infrastructure. And I just feel like, like even like, I mean, I'll talk about electric vehicle today, but even like with single charge of battery, you can run your house
Uh-huh.
5 to 6 days with only single charge. Um, I mean, you use your vehicle at the same time you can power your house 5 to 6 days. So even something happen, you are like, your main grid is disconnected, you can
Uh-huh.
still continue. So
Yes, yes.
there will be many,
Uh-huh.
challenges and opportunity that will be coming.
Now we are looking for the change. My brother-in-law, I bought this electric vehicle 2, 3 months before, and my colony also. Many people now recently bought. So now this is like a movement. It's now getting progress. Means now we
Yeah,
are
yeah,
looking
yeah.
the nowadays. People are buying a lot of scooty, means electric vehicle in India. It's a
Yeah.
boom in this sector industry. So for the new PhD and this new scientist, young scientist, is a very good opportunity to work in
That's right.
battery and energy
Yeah.
storage.
That's right.
Actually, I have to come in India because I also wanted one professor in Chalmers University. Actually, I was working at there. He was working in this battery, and he is a very big name at that time. He also got very big funding. So,
Okay.
so now he is working like sodium or some other, because lithium is like scarcity of lithium. So yeah, people are looking for other type of material of sodium battery. And
Yeah. I got, I mean, some funding initially to develop a electric car charging system. And then, I mean, recently I also got, but I still, I mean, I'm waiting for the student to join just to use artificial intelligence
yes,
and finding or developing some tools that could be utilized with a EV owner or EV business who has got not only electric vehicles but also like photovoltaic system and might be in other batteries as well, and developing some like energy management and tools that could be utilized just to get maximum benefit by utilizing both technology together.
Yeah, I told you, I want to tell you that we are also facing problem because we are developing this energy storage, but this is like optimization problem. We are improving like visible light, then half life is decaying, quantum will this is like one parameter we are improving, then other parameter is getting down.
Yeah,
Now we
that's
are in optimization type of problem. Then also we also need some AI or something to screen like millions of component.
That's right. That's why I mean, people are thinking now like having
Yes,
most of the project like interdisciplinary, like
yes.
having people from different area and formulating a project and then do the work.
Yes.
Anyway, Alta, should we start or?
Yes, we have 27 participants now, so we can
Yeah, I think
start
that's
it.
enough. Yeah.
Jangir, before you start, just a request to all the participants to wait after the session ends. If there is something important, I may convey it to you. Once I say that you can leave, then it would be better that you leave.
Okay.
So you can just start then.
Again, good afternoon, everyone. And this is my second lecture. So today I'll be talking about electric vehicles. So this is the outline of my presentation today. So initially, I'll be talking about some basics of electric vehicles. Then I'll talk about different types of technology that is available in the market for EV. Then I'll talk about different challenges and opportunity that we have with large scale EV integration in the electrical power grid. And then I'll show, some example of interconnecting EV with the grid. On top of that, I'll also talk about EV charger and EV motor drives. So I would like to cover everything which related to electric vehicles. I'm not saying like I'm expert on all of this, but I'll try my best to give you as much information as I can. So again, I'll start with the history of electric vehicles. So the first electric vehicles actually was built in 1981, again by a chemist. His name was William Morrison. He's from UK, but the car was initially built in California, USA. It was like 4 horsepower capacity, and it can drive maximum 50, I think 50 mile per hour, and with one single charge, its capacity was that it can run maximum 50 mile, and the battery capacity was like it was like 24 volt battery that was actually given like under the seat. But again, like after that, nothing much has been done for electric vehicle. Again, there was a number of reasons, but definitely one of them was like the battery price and the battery technology. But again, it was also some other reason that even there has not been much research even on battery technology as well, because there was some politics and probably um, there was something from that the country who was like producing petrol and gas, probably they also make some rule just to make sure that I mean the petrol and gas market is competitive, because if everything become fully electrical, then I think definitely it will have a huge impact on the price of petrol. Now, there are a number of reasons why electric vehicle is getting popular in recent year. And one of them is, the first one is that lower lifetime cost. Again, I mean, the upfront cost is still higher than the IC engine based vehicle. But if you even if you compare, if you see that I'm in the right hand side figure here, this one here, if you just compare that, you're having your vehicle for like 10 years, and the cost that we are considering, not only the upfront buying cost, but on top of that, maintenance and running cost. And here you can see that initially the electric vehicle cost was higher for the first like 4 to 5 years, but after that, I mean, it's getting lower, and the normal IC engine based vehicle getting price is higher. So this is one of the reason, I mean, recently that EV is getting popular. And that's it's lower lifetime cost because it is cheaper to charge than if you fill the tank with petrol. Electricity rate are also more stable than gas or I mean gasoline prices, because in I'm not sure in India, but in Australia, like if you see like the price like in 4-5 days, sometimes the petrol price changes like by 20-30 cent, but electricity rate is like a fixed for a year, so you know exactly what rate I mean you'll be paying. But that's not the case for the petrol price. And many countries, even like in Australia, if you buy electric vehicles, there are some grant and rebates, and you will get some tax credit when you buy I mean new electric vehicles. And even in Europe, many countries, they're actually providing huge subsidies. I mean, if someone buy the electric vehicles. And again, I mean, that higher upfront cost is actually typically, I mean, paid by that in the mileage range. I mean, it is expected that with one set of battery, without changing battery, you can run like 50,000 miles. So if you compare like this total lifetime, your I mean higher upfront cost will be actually paid by this higher mileage. Maintenance costs are lower as well with long battery warranties. And some country also, they are also providing either free or reduced toll while you are using like electric vehicles. And even like in the markets now, you can get like many model which is even less than the 35,000 in the market. But definitely, I mean, if you buy like Tesla S or their latest model, the price might be 100K or even more than 100K. The second reason why electric vehicle is getting popular, because its efficiency actually is very high if you compare with the normal IC engine based vehicle. Here I'm just showing one example which shows the efficiency of a Toyota model 2005. If you even get like 2021, the efficiency might be around 20%, where here this is like a 13%. So what it shows here, so for example, let's say you have a Toyota like 2005 model where you are taking, like, for example, let's say like 100-liter fuel here. Now with this 100-liter fuel, actually what happens inside, that out of this 100 liters, actually 76 liter will be lost in your IC engine. You can see like a major portion of the energy that you're getting as input is actually lost in your IC engine. And on top of that, another 8% of energy is lost as idling. Idling means that your car engine is on, but you are somewhere like waiting maybe in front of the red signal or in the traffic jam. So your engine is on, but you are not driving the car. So what happens if you add this to two of them? Like 84% energy is lost here. So at then only 16% energy is transferred to the drive line. And again, in the drive line, there is another mechanical losses, which is almost like a 3%. So at the end, you are only using 13% of the energy just to, for actually driving purpose. So you see like how inefficient this IC engine based vehicle. And as I mentioned, like even if you use the latest one, efficiency is around like 20%. So 80% energy is lost. But compare with that, if you use your like electric vehicle with inverter, converter, motors, overall, you will get efficiency more than 80%. So whereas like 20% and here is 80%. So if you see, like if you compare the efficiency, it is much higher than the IC engine based electric vehicle. So here I have just shown the like efficiency for different types, but what I'm just trying to say that this is much more efficient than the normal IC engine based vehicle. And as I mentioned, like it's the third reason. The first one is lower cost. This is like higher efficiency. So the third reason is that it actually needs very lower maintenance. And it needs lower maintenance because you don't have to change the oil. You don't have to change the spark plug that you do in your normal IC engine vehicle. You don't have to, there is no actually smoke check as well. There is no timing belt, and you will have even like long lasting brake. And that's why your vehicle will have much lower maintenance than if you compare with like your normal IC engine vehicle. And here you can see that comparison. So the first one is that IC engine based EV. Second one is hybrid. Third one is plug-in hybrid, and the fourth one is fully battery electric. And I'll talk about briefly what are the difference in between these three. I think you might already know, but you see that here, this is much lower than that one, and these are the corresponding factor here. I mentioned why this is actually lower. So it says like up to 35% decrease cost over time. fourth one, the running cost also like significantly lower for electric vehicles. So here, I mean, again, with the Sydney electricity price, we have compared the per kilo running cost for pure electric vehicle, hybrid electric vehicle, and then IC engine based electric vehicle. And you can see for pure electric vehicle, so the running cost per kilometer is 0.5 cent, whereas for hybrid electric 3 to 6 cent per kilometer. But for IC engine based vehicle, it is 10 cent per kilometer. So you can see here that for IC engine based vehicle, so the running cost is 20 times higher than electric vehicle. So that's why, I mean, initially I mentioned that, I mean, if you compare the lifetime cost, electricity, electric vehicle is cheaper than IC engine based vehicle. Another important factor is that emission, because transportation sector, they are responsible for like almost like a 20% of the overall emission. And to make the country like net zero by 2050, I mean, the transportation sector, needs to be, decarbonized as well. And to do that, definitely, electric vehicle can play a significant role. And again, here you can see that like emission for electric vehicle, it has got very minor, and that's nothing if you compare with other conventional based IC engine based vehicle. So if you go in the market, there are like different choice that you can have. So you have both either battery as well as fuel cell based vehicle. And again, for battery, you can have pure battery, you can have hybrid, and also you can have plug-in hybrid. And then you also have got the option for fuel cell based EV as well. And each of them has got their own benefits and limitation. And based on your like preference and also the area that you'll be driving the vehicle, you can choose, which one would be like the most suitable for, particularly for your case. So in terms of technology, there are three types, as I mentioned, like the hybrids, plug-in hybrid, and pure electric vehicle. And I'll just probably might already know, but for hybrid, you have got both motor battery, and on top of that, you have got internal combustion engine as well. And then there is a power management unit, which will actually manage the power is coming either from battery or from like your IC engine. So you have, while you are driving, in most of the cases, it uses power from IC engine. But what happens, like when you deaccelerate or when you use your brake, during that time, the motor like operate as a generator and it produces power. That power is stored by battery, and then this power is again utilized for running your vehicle. So this type of vehicle is quite economic if you run in the CBD area where you have got like frequent traffic jam and also frequent signal. But if you drive in the rural area where there is no traffic jam, there is not like a frequent traffic light, this vehicle might not be that economical. The second one, in terms of like design, almost same. Only difference is that here you can charge the battery from outside plug. So that's why it's call it like plug-in hybrid vehicle. But again, it has got both IC engine as well as battery plus electric motors. And this one, as I said, like it's mostly passenger, but there are also some plug-in versions for commercial vehicle. For example, the truck, buses, train, scooter, military vehicles, and so on. And the last one is a fully electric vehicle where there is no like IC engine. Now, if you are thinking like to buy electricity, I mean, what are the things you need to consider? So before buying the electricity, electric vehicle, few things you need to consider. One of them is that what sort of charging access you have, what sort of range you need, how often you'll be driving your vehicle. Is like a quick charging critical for you? Do you need to charge your battery within 20 to 30 minutes, or you can have overnight charging? And I'll be talking about charger level, but also you need to know what sort of level your vehicle will support. And then also very important thing that you need to know what would be the battery life and what sort of warranty they will provide. So these are the things you need to consider if you are planning to buy an electric vehicle. But before that, I just like to ask, like, am I going in the right speed, or do you have got any questions so far that you would like to ask me?
Yes, sir. So I'm Saujanya Rath here, sir.
Yes.
Sir, I've just got one doubt, sir.
Yes.
Sir, in terms of battery, when we compare, the cost of the battery is very high, as I have heard. Like 10 years, one has to replace the battery of a EV. So that cost is very costly. So it is said that if the customers are traveling more and average in a day, then one should consider EV. So, sir, can we have hybrid in the way like we can have both conventional fuel as well as electric vehicle in a car, or that is not possible?
Yeah, that's the hybrid one. That's definitely possible. And as I mentioned, that the hybrid one would be economic for you. If you drive in the city area, because when you have got the hybrid, it only produces electricity when you deaccelerate your vehicle. And as you know, if you drive in the CBD, where due to the traffic jam, frequently you have to use your brake, and also the red signal you have to brake. So that's the time it will be producing electricity. That's why I say during the CBD area, it makes sense to have hybrid. But you're right that still that's one of the reasons why electricity pure electric vehicle is not that popular, because the battery price is high. But the way that the battery price is going down, like every 3 years, it is going down like almost 50%. And we believe that that trend will continue. So that's why next 5 to 10 years, I think the price even would be even. But even still now, if you compare the lifetime, still we have found that electric vehicle is cheaper than the normal IC engine based vehicle. But definitely, the upfront cost would be higher, because its buying cost is higher. Does it make sense?
Yes, sir. Yes, sir. Thanks a lot, sir. Thanks.
And also, am I going the right speed, or are you finding difficulty to follow me?
We don't have any issue, sir. We are understanding it very well.
Okay, thank you very much. So next I'll be talking about the internal components, main components of an electric vehicle. So you might know that the main components of an electric vehicle is motor with controller, and then the charger, the batteries, and inside the converters, and then it has got some internal contactors as well. So here, I mean, in my talk, I'll mainly be highlighting the charger. I'll not be highlighting the battery today because I'll have, I mean, separate lecture on battery, but I'll also be talking like that inverter and the motor drives. So you know that there are different types of motor. So as electrical, I think all of you know about there are different types of motor available, like DC, AC, and AC also, and DC we have got brushed, we have got brushless. AC you have got induction, synchronous, also switch reluctance motor, and also synchronous we have got permanent magnet synchronous motor as well. So different manufacturers actually use like different sort of motors. So I mean Tesla, they mostly use like the induction motor. The Honda, they use permanent magnet brushless motor. Toyota also use permanent magnet brushless motor. But the way that most of that EV company, they are probably in the coming years they will go for more like a permanent magnet synchronous motor because it has got very higher energy density, and also like you know that when you've got permanent magnet, you don't need like another exciter as well. But definitely, it has got problem with that permanent magnet because for permanent magnet we use materials, and definitely, that has got some limitation as well in terms of like total stored capacity in the world. So that's why other machine like Swiss reluctance motor, that I think we think that might be popular as well, but still there are some issues with the Swiss reluctance motor in terms of the torque performance, but there are number of research is going on to improve the torque performance of Swiss reluctance motor, and if that problem resolve, I think that even would be popular in the EV industry as well. And as I mentioned, like most of the motor, they are comparatively, they have got very high efficiency. Here if you see like most of them like more than 90%, only one of them is like within the 85 to 90% range in the peak efficiency. And the controller, definitely that's a very important part of the drive system of an electric vehicles, because that can increase the efficiency, reliability, and also it can extend the battery lifetime as well. So that's why although there are many good controls already available, but still there are many more resources going on to improve the performance of the controller. The charger, as you know that there are again different types of charger available. For example, the residential charging station, you can have it on your own garage, where you might have like single phase slow charging where you can charge your vehicle overnight. It can take like 4 or 5 hours to fully charge your battery, but in the most cases in the night time you are not driving, so you can easily charge the vehicle overnight. The second one, charging while parked. So it could be like in some public charging station, it could be your university, it could be in your workplace. And then the third one, it could be some fast charging at public charging station. So probably sometime while you are driving in the highway, And if you need to charge your battery, you can just have a cup of tea, and then within 15 to 20 minutes, you can fully charge your battery using DC fast charging. Other fourth option, which is not that popular, that is battery swapping. That you can have some um, shop which have got batteries, so you can just give your empty battery to them and take another fully charged battery. But I think that might not be popular, because if you are, for example, if you're driving like BMW, you won't be able, you won't be interested to give your battery and then take another one. So that's why I think this idea might not work. And in terms of the charging standard, there are 4 level of charger: level 1, level 2, level 3, and 4, and that actually depends on the voltage and current rating. So level 1 and 2 is either single, 1 and 2 is either single phase, or it is like a 3-phase AC, and then 3 or 4 level, that's mainly DC, and it has got very higher current rating and also very higher power rating, and it takes very small time compared to other charger. So here you can see this is like more than 4 hours, but this one is like a 10 minutes just to fully charge the battery. Probably I saw one question in the chat, because I cannot see the chat. Can you please repeat the question if you don't mind? Would you please-
Sudhalayan did. Is there any issue with
Sir?
your
Yes, sir.
unmuting? Please ask.
In commercial vehicle, how will you manage the weight of the batteries? Because in the for same capacity, the battery is having higher weight when compared to engine. Then how will you manage the weight and size occupied by the batteries in a commercial vehicle such as trucks?
So you mean that fourth option? Or sorry, so you are asking like, can you please repeat it again? I just missed some point.
How will you manage the size and the weight of the batteries, sir? Because
Okay, so I understand now. So that's a good question. But you might know that the latest lithium ion battery that has got very compact size. Like the size is it's a very thin, and even you can just put out like on the lower part of this vehicle, and you can maintain you can put that battery there. But having said that, when you have got a very heavy vehicle, it is expected that heavy vehicle would be popular, which would be running by fuel cell, because for heavy vehicle, you are right that you need large amount of vehicle, and also on top of that, the heavy vehicle also, they daily their driving range is much higher than the normal vehicle. So it makes sense for them to use fuel cell instead of hydrogen. So that's probably the market in Australia, but I believe that in many other countries, people believe that the light vehicle, that's like the car that we drive, that might be popular with the battery or even like hybrid. But for heavy vehicle, bus, truck, train, I think fuel cell one would be the better one compared to the battery one. But still the battery is possible, but the fuel cell one will have um, better advantages than the battery one.
Thank you, sir.
Thank you.
Then I had one question here in that slide of chargers, the fourth type that you mentioned is battery swap. Now, usually we will not be interested in battery swap if I own the battery.
That's
But
right.
if the model is like that when you buy a car, the battery is not given to you, but some rented battery is given to you for you to move, then I don't mind what kind of a battery I get. And maybe that system, that methodology then may become a little bit more popular. I
Yeah, I
don't
mean,
mind which kind of battery I'm using till I get it, till I get the battery to travel. So from place to place, if we have got battery swaps, maybe it may work out. If
yeah, I
I
mean, that's
don't
the
need
idea.
to
I mean,
pay the
that's why, I mean, some people, they actually started that business, but
okay,
unfortunately that business, did not get that market as expected, because
mhm,
like the people who are running uh, like old vehicle, or less expensive vehicle, they actually don't mind to swap it, because you don't have to wait to charge your battery, right? You're just giving one, taking one, and then you can
okay.
go, right? Um,
And one more
and I mean,
question was,
and also you have got the battery warranty as well, right? So they will maintain the
if the
warranty.
battery itself is not sold with the car, if I buy a new car but I don't pay for the battery, I only go for the rented battery, then that may be the
Yeah,
business will work out.
yeah, that's that idea might be, but I think most of the vehicle that when you buy, actually you're buying with the battery.
Right,
But
right, right.
but if that concept is start that you're just renting the battery, I don't know, that's but that concept actually they started. It's not like
Working.
yeah, I mean they didn't buy the vehicle without battery. They actually bought vehicle with the battery, but
And
it's
then,
just like
people will not part away with their new battery, obviously.
So that's why, I mean, that business actually didn't get market. So that actually stopped.
And one more question is like when you say charges in under 15 minutes, this would be okay when it is new. What happens after some years?
Well,
Will it
again, I
still be
mean,
able to do it?
after some years, definitely, I mean, the battery capacity will, I mean, drop. And then the time, I mean, slightly vary, but it will not be very, very significantly, because
My next question is based on that only, that if the charging time goes up a little bit, will there be some parameter or something to decide that now is the time to throw up the battery? The life of the battery is over.
well, I mean, so it's not only the charging time. There will be many other indicators which will tell you that your battery's lifetime is going. I mean, this is almost over. So
Okay.
your SOC, and there will be many other factor as well. So you
Okay.
start. I mean, you can also monitor your state of charge, state of health. There are some many monitoring device in your vehicle that will tell you, I mean, how well, I mean, your battery is running.
Right. Right. Okay. Thank you.
But this is one of the factor. And then other one, that next generation charging, that's probably will come in future, but still that is not popular because it has got very low efficiency. That is wireless power transfer. You might heard about that technology. That is already, there are many research project is going on, and if that technology get matured and efficiency get higher, then even you can charge your battery like within a second or minutes while you are just driving. So the charging pad would be under the road, and just like within a second, I mean, your battery can be fully charged. But again, as I say, so the power will be transferred like the induction principle without using any wire. But still, I mean, even with considering that gap, the efficiency is very, very low, and that's why still that is not commercially viable. So that's for like electric car, but also for electric bus, there are similar they are slightly bit different, but there also here we have got two options. One is like
Sir?
plug-in. and another is called wireless charging. So here,
Sir,
yes,
am I audible?
yes,
Yeah, sorry to interrupt, sir.
no,
Sir,
this is
in
okay.
the previous slide, frequency is not mentioned in the standard.
Okay, so I mean, you mean the frequency for supply voltage or
Yeah,
here,
yes, sir. For AC,
I mean,
yeah.
for AC, I mean, it could be like 50 or 60 hertz. And DC, you know that there is no frequency.
Yeah. And sir, the standard which it follows, can you please quote it?
Okay, so I mean, I'll send you some IC standard that I have. I'll send it to I mean Altaf, and Altaf can distribute to everyone.
Sure, sir. Thank you, sir.
Yeah, no problem. So for the bus, also, I mean, initially we have got two types of charging. One is called plug-in, which is like a standard as I mentioned previously, but definitely for buses, we only use like, uh, 3 or 4, level 3 or 4. And typically it use like higher capacity, 50 kilowatt or 100 kilowatt AC/DC charging. And it could be up to 350 kilowatt. But with the problem with the plug-in system that I mean, they actually run like for the whole day. So if you use like that plug-in charging system, the problem is that you need to use very higher capacity of the battery. So if you use this sort of charging, so that's why instead of that, if you use that second option, which is called like pantograph, if you use that charging system, you need the lower battery capacity because you will have the option of frequently charging your vehicle, because while you're running your bus, I mean, sometime you will be like in the bus stop, you will be stopping just to getting extra passenger, or also some passenger will alight the bus, and during that time that charger will automatically connect with the charging system that overhead wire, and it will charge the battery. And that's how you have the frequent option of charging the battery. And if you use this sort of technology, you need lower battery capacity, and that's why I think this is more popular than the plug-in charging system for the buses. And same for like the other one, it has got the option for like wireless as well. And here you can see that the charging pad. So as I mentioned, like it will have like under under cover charging system, and while here it comes on the pad, and the battery will be uh, fully automatically charged. But again, same thing, the technology is not matured and it's not that efficient. Now if you think about that electric vehicles, mainly there are three challenges why still the number of vehicles is not higher even in India or in Australia. And one of the challenges in the range, because initially
Can I?
Sorry, would you like to ask any question or?
I just want to add some point with respect to the previous slide, sir.
Okay.
This is Chellamal. Sir, the previous one we had the third type of charging is nothing but inductive charging, sir. I read in an article in China that just 2 years before or 3 years before they had a like how it is shown here in the blue color, inductive charging, sir, wireless charging. They have laid a road of 1 kilometer where they have wireless charging systems are underground.
Yeah.
And using transformer action only the charging is taking place, and the China is testing that wireless charging system. This article I read in.
Yeah. I mean, yeah, you're definitely right. Not only China, but many European countries, they are also testing.
Yeah. And the road is, I think it is a special glass which is used for laying roads. So that main road will be like our normal road. Whenever you want to charge a vehicle, you can divert and run your vehicle on that glass road, which is specifically used for wireless inductive charging. This article I read in a newspaper somewhere. I read. Thank you, sir.
Yeah,
Thanks, sir.
that makes sense. I mean, if you like, only use, for example, for bus, that makes sense because you are having only fixed number of road. But if you use your like a normal car, and then I mean, you can go like anywhere, and if you have only one particular road, and that might not that be convenient for like a small car. But you're right. I mean, there are many demonstration is going on, as I mentioned that would be, I mean, popular in coming years. But again, I mean, they are testing, and at the same time there are also number of research that's going on to improve the efficiency, to make it even like more cost effective. But anyway, thanks for adding that part. Oh, sorry. So here I just would like to mention that there are these like mainly 3 challenges for electric vehicles. One of them is the cost, second one is the range, and third one is the charging infrastructure. But as I mentioned previously, that battery price is dropping significantly, almost like 15% per year. So every 3 years is almost like getting 50% off. And if that trend continue, as I said, like next 5 to 10 years, the price even would be like even with the ICE engine based vehicle. The second challenges in the range of EV, because that the conventional EV initially, its range was like 130, 135 kilometer. And with those range, if you want to have like a long drive, that range might not be enough. So you need to charge your battery while you are driving your EV. But in many countries, still there are not enough charger on the highway. So that's one of the reason. Still the number of electric vehicle is not high. But here, we just did some analysis just to find out on an average people how many kilometers drive per day. And in Sydney, actually, we analyze like 62,000 vehicle, which is actually traveling in some part of the Sydney. And we found that almost 88% of the people, they just drive less than 30 kilometers per day. So even with this range, with the level 1 charger, even it's like sufficient for them for their daily travel. But as you know that the recent Tesla, they have got even range like 600, 700 kilometer. So what I'm trying to say that range is no longer an issue for most of the people. If they would like to buy electric vehicles. And the third option was like the infrastructure, mainly the charging infrastructure. So that is, I think, the biggest barrier for EV market. So still many countries, they don't have that infrastructure. So that's why people, they are afraid to buy electric vehicle. But once we have that enough charging infrastructure everywhere, I think people would be more interested to buy more electric vehicles. And again, the future charging system, as I mentioned, it could be in your home, it could be in your office, it could be in any industry, shopping center, and then it might be connected with the either like on-site solar generation, or it might be connected with the power grid. But it does make sense. If we could have on-site generation, that's how if you compare the overall efficiency, that would be much higher, because if you use the normal power system, and power is transmitted that very long transmission and distribution line. And if you use like the normal source of power, like coal or gas, actually that does not make sense, because still in that case efficiency would be lower, and also it will produce greenhouse gas as well. Now this one actually shows that percentage of electric vehicle. I think that figure is probably 2 years old, but I think currently in terms of percentage, Norway is leading. So they currently have like almost 40% of their vehicle actually electric vehicle. And the reason is that Norway actually giving huge subsidy the people who is buying that electricity. And then followed by some country, then USA, China, UK, Australia. But as I mentioned, like that, from now to next 10 years, so the electricity market will have like a revolution. And in Australia, I mean, it's predicted that at least like the 40% of their vehicle would be electric vehicle by 2030. And even I'm like, think about worldwide, it's like that, it actually it would be increased like exponentially all over the world. And once you have got this like, massive rise of electric vehicles, it would actually have a huge impact on the power grid as well. So here, that's the top two figures that actually shows that in the black one, that existing demand. Here, this is for Texas, and this is for California. And that's the blue one. You can see, I mean, if they're like 100% vehicle is electric vehicle, then their demand, you can see it will actually reduce. I mean, it will increase significantly. And same for like the I mean, bottom figure that shows the demand in Australia. So it's not only Australia or USA, but actually it would increase the demand, I mean, all over the world. So that's why, I mean, we need to find out a way to intelligently manage the charging and discharging of electric vehicle, just to make sure that it does not have huge impact on the electricity. Because if your demand is increases significantly, that means you have to upgrade all the infrastructure significantly as well. And even if that is the case, the growth of EV, even it will be delayed, by the limitation of the, I mean, power grid. So that's why, I mean, people now currently thinking about how we actually intelligently can manage charging, and at the same time discharging as well, so that it does not have negative impact on the grid. So if we don't actually manage the charging and discharging, as I say, like, it will have potential impact on the network. And in most of the cases, I mean, most of the power industry still they are not certain, like, what sort of actual impact they will have in terms of like, power quality, and also like the voltage stability, peak demand, and so on. To do that, actually, they are currently doing, I mean, different sort of studies just to quantify, what sort of impact they might have, considering different sort of like integration level, considering different sort of charging pattern and so on. But still, as you know, that this is like a mobile battery, so there are so many uncertainty. So it's not easy to I mean, accurately quantify what could be impact on different parts of the network. But although there are like a number of challenges, but there are some opportunities as well, mainly using that technology, vehicle to grid. So you might heard about this technology, that using that you can actually sell the stored power in your battery to the grid, or even you can transfer to other vehicle. You can supply to it your own home, or you can sell it, transfer your power to the microgrid as well. So sometimes people call it like a V2X, and X mean, as I say, like it could be another vehicle, it could be grid, it could be home, and it could be microgrid as well. So it is a huge source of like storage, and if we can utilize those stored capacity, it actually could be utilized to solve many of the problems that is introduced by renewable energy. For example, like voltage stability problem, frequency stability problem, peak demand, and so on. So it will not introduce any additional problem, but on top of that, actually it could be utilized to solve many of the existing problems that is being introduced by large scale renewable energy integration. Although this is possible, but still there are many challenges that we need to address, because as you know, that battery could be either source or sink. It has got very fast reaction time. So if you again don't control charge and discharge, as I said, it could have like a rebound effect. And this is like a moving storage. So there are many uncertainty, like the location. It depends like state of charge. It depends on how much battery you have used. It depends on the like preference of the vehicle owner, is the location. So there are so many uncertainties as well that we need to address before the the positive impact, as we mentioned, that it can produce. So next, I'll show some like some research outcome that we have got from our group. But before that, I'd just like to share one news that here, during the COVID time, many people, they are not using that vehicle frequently. So like many people, like they are just using that vehicle just to buy or to charge their battery during the peak time, and then sell that during that off peak time charging, and during the peak time they are selling that battery. Here that is just like this person, he just used that battery, and he actually earned more than $1,000 like in a year. So there is a already there is a proof that using that V2G technology, you can actually earn money while you are using your vehicle. So with that, I'll just give like 5-minute pause, and I'll just see whether during that time, if you have got any question or any comments, feel free to share with me. I'll just take like 5 minutes break.
If there are any questions, please put it up either on the chat box or directly ask.
Altaf, still again, we have got the problem with your sound system today.
Again,
in the beginning, you are fine, but now There is a problem with that. Your sound.
Maybe after 1 hour there is some issue.
So how many participants now we have? 35. So if you don't mind, I'll just take like a few minutes and just like quick introduction from you, if you don't mind, just like
Yes, sir. We can.
currently you just say like which institute you are from and what you are doing. That's just like a 2 sentence. So should
Good
I?
afternoon, sir.
Yes.
My name is Arpita Benjamin. I'm from NIT Warangal. I'm currently pursuing MTech in Power System Engineering.
Thanks, Orpita. Who'd like to go next? Anyone? I mean, just.
Thank you.
Yes,
Good
sir.
afternoon,
My
sir.
name is Sanjeev Roy, sir. I am from NIT Warangal, Power System Engineering in MTech.
Thank you.
Good afternoon, sir. This is Dr. Chellammal from SRM Institute of Science and Technology, Chennai. And I am an associate professor. I am currently working in the area of power electronics drives for EV applications. Thank you, sir.
Thank you.
Sir, good afternoon, sir. Good afternoon, sir. I'm Saujanya Rath. I'm currently pursuing MTech in Smart Electric Grid from NIT Warangal. Thank you so much.
Good afternoon, sir. I am Mrs. Fabia Akbar, a research scholar in NIT Warangal. I am working under the area of design of inverters for induction heating applications.
Thank
Good
you.
afternoon, sir. Myself, Ronak Naik. Now I'm pursuing MTech on Smart Electric Grid from NIT Warangal. Thank you.
Good afternoon, sir. I am from Nagpur. Myself, Sheetal Kevte from YCC Nagpur. Sir, I am working on the power system area. Thank you.
Good afternoon, sir. I'm Shudipto Mitra. I'm pursuing PhD in NIT Warangal now. Thank you, sir.
Good afternoon, sir. I am Harshvardhan Hemant. I am pursuing MTech in Power System Engineering in NIT Warangal. Thank you, sir.
Good afternoon, sir. Myself, Sumit Mehta from National Dairy Research Institute, Karnal, and I am doing PhD from here only. Thank you, sir.
Good afternoon, sir. This is Jamila from Anna University, Chennai, doing PhD in renewable energy systems. Thank you.
Thank you.
Good afternoon, sir. I'm Gagan, and I'm doing my PhD in electrical engineering from IIT Bombay. Thank you, sir.
Good afternoon, sir. Myself, Ravi Kumar, currently doing PhD in NIT Warangal.
Thank you.
Hello, sir. Vijay. I'm doing MTech in Power Systems Engineering at NIT Warangal.
Thank you.
Good afternoon, sir. This is Sumbul Hassan Abdi, Assistant Professor, Electrical Department, Sardar Patel College of Engineering, Mumbai. Currently pursuing my PhD from IIT Bombay.
Thank you. Anyone?
Good afternoon, sir.
Yes. Yes.
Hello.
Yes, I can hear you.
Good afternoon, sir. This is K. Hashni, sir.
You have muted again. Yeah.
I'm sorry, sir. This is K. Harshni, sir. Recently,
Yes.
I have got admission in a PhD in NIT Warangal, sir, of
Okay.
Electrical Engineering Department. Sir.
Have you decided your topics or not yet?
Not yet, sir. Going on, sir. Just I want to listen your topic, sir. So based upon that, I'm having yet to decide, sir.
Yeah. Good luck with your PhD. Thank you.
Thank you. Thank you very much, sir.
Anyone else left?
Yes, there are many left. See.
Okay. If not, then I will again share my screen and start.
Whoever has logged in with HP1, please log in through your proper name. And you are also, I don't have a record for you. So please,
So Aldab, I don't know. I mean, probably everyone is probably having issue with your sound. Am I right? What about other people? Can
Yes, sir. It's breaking, sir.
Yes, sir.
I don't know what happened. Like in the beginning, your voice was clear, but now the voice is breaking. Okay, now, as I mentioned that, I have done some project on electric vehicle charger, and now I would like to show you some research outcome from that project. So initially, I mean, we developed a single phase onboard car charging system. And here you can see that the size of that, charger. So initially we developed a single phase 4 kVA, and the overall efficiency we managed to get more than 98%. And the switching technology, we use silicon carbide MOSFET. And as I mentioned that, so the latest two switching technology, one is silicon carbide and another is gallium nitride. So here we use silicon carbide, and switching frequency was actually 100 kilohertz. And initially the AC, I mean DC voltage range was, AC was 110 to 250, DC was 150 to 400 volt, but later, I mean, we have planned to make it even higher than that one. We use that, Texas Instrument DSP firmware platform. And for the communication, we use like wireless for external communication and 3 or 4G, I mean, initially, but now, I mean, you also have like 5G as well. And we use actually not transformerless, is with like transformer just for the isolation purpose. And here we use a very high frequency transformer, and one of my colleague who is like having got a patent, and he's expert on high frequency transformer, and even with the transformer he got like more than 99.6% efficiency. So that's why we managed to get overall efficiency like more than 98%. Now I'll first I'll just briefly talk about what capability it has got and what sort of like control we have used for like the inverter, and then I'll show you some experimental result that we have got in our lab. Now the charger that we have developed is not like a simple charge just to charge your battery, but here our objective was more like including different function with that charger. So that's why we call it like a multi-function single phase EV charger. And the function that we included with the charging system, that it can have either grid connected, or it could be like off grid. So when it is like grid connected, it can actually provide all the function that is mentioned here. So it could be either vehicle to grid or grid to vehicle, which means that charging or discharging. It can also provide different ancillary function. For example, it can provide reactive power support. It can reduce the harmonics. It can also regulate voltage as well. This is just the summary that the control that I already mentioned. That here I call active control, active power control, which just control the active power for charging and discharging. And then we have got the harmonic controller. So what harmonic control actually does, it extracts the harmonic component of the load current just to provide the active power filter operation, just to eliminate the harmonics from the source of the, from the main source of the current. And then it also determines the reactive power, which might be need by non-linear loads, just to provide that STATCOM operation. And it also regulate voltage at the point of common coupling, which is also same like the STATCOM operation. So STATCOM, you might know that this is like a static synchronous compensator, which is a fax devices, which is actually used with renewable energy. When you need like additional reactive power support in the system. So if you use this one, it can also provide that function, and you might not need additional STATCOM in the system. This is the overall circuit. Again, our topology was not new. This is like standard DC to DC and then inverter topology. You will find it many papers in the literature, but what our contribution here is mainly in the control side, and all the controls actually are applied through this PWM switching in the inverter. And here you can see like for all the control here, like active power control, harmonic control, voltage control, reactive power control, like all the input signal and the reference signal that we have used. So initially we tried with the PI control, but later also we tried advanced control as well. Now with all this control, we have got this different reference signal that we are getting, and at then all this reference signal is coming here, which is actually at the end. Initially we have got like as it is like a single phase. So from like initially we convert it from single phase to alpha beta, like quadrilateral axis with the 90-degree phase shift. And then we have got like a DQ frame. From that DQ again we back to alpha beta, and then we have got like a single phase, and then we applied that control signal to the inverter through this PWM, and that's how it actually ensures all the control function that I mentioned. And here you can see that like initially we are just considering that it's connected with a home which has got some non-linear load, which actually distort the current signal and produces harmonics. Now here I'm just showing some result, and here initially the load that we consider in the home is like purely active power, and here it is just showing that grid to vehicle, that means from grid the power is coming to charge the battery, and it's connected to the home, so some current is going to the home as well. So here you can see here up to that point there was no, but again when started charging, there is a like a battery current, but it's positive, negative, just like direction just for charging and discharging. So up to that point there was like no current, but here it actually started charging. Next we consider both active and reactive load. So here we are considering like real power and also reactive power with lagging power factor. So you might know that, I mean, in our home, most of the load are inductive. So if you consider like most of them, like your AC, your washing machine, freeze, all of them has got like induction machine, which has got inductor. That's why we have got lagging power factor. And you know that lagging power factor, when you have got lagging power factor, it actually increases the losses in the system. Because that power is not used actually by the load, it actually is some sort of loss in the system. So what we does here, like here you can see like in the second one, like we have got some angle difference between voltage and current. So it's not like unity power factor, and this angle difference you can see, this is like a capacitive. So that means it's actually like providing the negative bar to the system, because the system already have got the positive bar. That's why it is actually neutralizing that reactive operation, just to make sure that, I mean, the overall system has got lower losses, and also it is like more economical as well, because in most of the cases in your home, if the power factor goes beyond like certain rates, for example, like 0.95 or something, like in different country it could be different, but if it goes beyond that, actually the power utility, they actually provide some penalty to the resident as well. So if you have this type of charger in the house, it actually solve that power factor problem. Next one I'm showing like it performance to reduce the power quality problem. So here, I mean, in this case, we are considering this home has got some non-linear load, and this non-linear load, what is doing actually, this the current that is getting from this like main sources IS, and here you can see this IS is like very distorted. It's not sinusoidal. And when it is not sinusoidal, that means if you do like Fourier analysis, you'll get like like it will have so many harmonics in the system. And the reason the harmonics, you can see that's the current that's coming in this home, which is not good, because it will increase the losses all on your appliances. That's how the power will lose. It will reduce the lifetime of all the equipment. So to solve that problem, I mean, if we have our charger, actually what it does, you can see in the next figure, that's this charger, it actually analyze this current coming to the load, and then it actually subtracts that harmonic components, and then the controller operates in such a way that this harmonics is coming through this way. We also found that this is actually not compromising with the battery performance. So only things it will compromise, that it will reduce the overall capacity of that inverter, but other than that, it will does not have any impact on the battery. Only reduces some capacity of that inverter, just to use for either to solve that harmonics problem, or solve that power factor problem. And here you can see that the source current is almost like pure sinusoidal. And here also, like you can see, like initially the total harmonic distortion was like 25%. After connecting this one, it is reduces to 3.2%. And in most of the country, the standard is that it has to be less than 5% total harmonic distortion. So the next capability this charger has got is called vehicle to vehicle power transfer. Because what can happen that, I mean, if you drive your vehicle in the very remote area, and it sometimes happen that your battery is flat and you are not getting any local charging system. So in that case, I mean, what we can do, I mean, if there is another vehicle in that region and both of them have got the same charger, just using another one simple cable, they can easily transfer power from one vehicle to another vehicle. The power circuit will remain same, only the control will change. And we actually compare the performance of our power transfer performance from one vehicle to another vehicle with a US patent, and you can see the patent number is given here. And we have found that, I mean, our one, in terms of like with the US patent, their concept was that they used like another additional battery, and then I mean it will transfer that power from that battery to the vehicle, but it has got a certain limit as well. So in our one, I mean, we don't need any additional battery, and it's just like a simple cable. And this is this sort of arrangement, I mean, currently, I mean, as I say, like, if your battery is flat, then, I mean, you need like a big truck like that. They will come and, charge your battery, and that's how probably you can drive. So like, there are many insurance company, I think they provide that sort of service for the roadside assistance. So if we have that sort of charging technology that's I mentioned, that's probably we don't need that additional huge truck. Again, I mean, only simple things that when it is just using the additional, it's just like operate like a both are like a DC to DC converter, and that's how it's just like buck boost operation. That's how it's just like a transfer power from one to another one. But when it is grid connected, it's DC to DC, and this is one is DC to AC. But when it is like one vehicle to another vehicle, and both of them is just like a DC to DC converter. And here also we prove that when it's connected, one of them we're using the two battery, like one of them charging and another is discharging. You can see it from here. Any question on the charger that I mentioned, or any comments as well? Yes.
Now am I audible?
Again, I can't like understand you actually. Your voice is so like noisy.
I left the meeting and again joined.
But
Just check
still it
with-
didn't solve that. You can try it again, but this time still it doesn't solve that issue. I mean, I just couldn't understand. Initially it was fine, but why like at later stage, I mean, you have got that issue.
Maybe the YouTube live is also going in my laptop itself. That is why. I think so.
Anyway, I mean, probably I'll show like another like research outcome that we have done in our lab. Then I'll pause for today, because the other application that I'll be showing, I mean, that's involved like the photovoltaic system as well. So that's why probably we'll discuss.
Excuse me, sir.
Yes. Yeah.
This is Fabia Akbar, sir, research
Yeah.
scholar. Sir, is there any scope of multi-phase induction machines in EVs?
I think probably yes, but when you have multi-phase, I mean, then probably you need like the corresponding control that might need to update it as well. But I mean, so far, I mean, I haven't seen any of these existing electric vehicles.
Okay.
But that's probably it need probably further research and also update the control which might be suitable for multi-phase induction motors.
Okay, sir. Thank you.
Sir,
Definitely,
sir,
that's the
am
like
I audible?
yes, you're audible. Yes.
Yeah. Sir, it's a very basic conceptual question. Sir, will reactive power, if EV is supplying to the grid in V2G process, then is the battery getting degraded in that process in any way?
No, actually, it does not have any degradation of the battery. Only issue is that it is actually using some capacity of the inverter. We done experiment and we shown that only, for example, let's say, I mean, your inverter is 5 kVA, for example. So then, I mean, if you use like, for example, let's say 0.5 kVA for like, this harmonics and reactive power compensation, then only the remaining 4.5 capacity you can use just for your battery charging and discharging. So that's only that limitation you have. But other than that, I mean, we found that it does not affect the because it's actually coming from that you're controlling your inverter, not from the battery.
Yes, sir. Got it.
Thank you. Well, then I'll discuss like another research outcome that we have done relevant to this is more like induction motor drives. Recently, one of my PhD student, he completed his PhD. I'm not showing like all the result here, but just like one application from his thesis. But other results, I mean, are already published, in journal. So here, actually, what he has done, he has tried to develop some robust control technique just to cater for the effect that is actually come from increasing the temperature, because you know that when you are running your vehicle, definitely your temperature will change. And when there is a change in the temperature, it has got effect on the resistance, right? And when it has got effect on the resistance, there is a relation between that, torque as well as speed with the resistance as well. So if we don't cater the effect of, I mean, that thermal, it might actually have got, I mean, impact on the overall performance of, your induction motor or whatever motor you use. So here, I mean, we initially focus on the induction motors, because as I said, like, although there are many motors they're using, but still, I mean, some of them they are using induction motor, because as you know that induction motor has got some advantage in terms of its robustness as well as cost. So, and one of them, I mean, the big one is the Tesla, who is using induction motor. And these are the problem that, I mean, would like to solve, I mean, in one part of his thesis. So as I already mentioned that the increase in operating and environmental temperature of a traction motor in the electric vehicle causes the variation in its performance result that actually comes from the thermal duration of the vehicle speed. And to do that, we try to use the concept of linear parameter varying controller. And this is the mathematical representation of that LPV system where like this is theta, that is function of time, and that is variable. So probably you know that, I mean, when you have got any system, I mean, if you would like to use or if you like to design any control, in most of the cases, I mean, you need to find the transfer function, or like other way you can see like that, you know, a small signal, I mean, model of that particular system. So here we are just representing like in terms of your output, in terms of the system state, in terms of the, you know, control input. So we have got here, we have got like induction motor, which has got some mathematical model. We have got the drives, it had also some mathematical model. So all that, like, you know, differential as well as algebraic equation, we represented in terms of this matrix representation, because that's the I mean, representation we need if you would like to develop, you know, any, I mean, linear control. And here, I mean, initially we tried the linear control. And again, in the control, probably you know that we do have like PI control, which is normally widely used because it's very easy to design. But when there is a like a considerable change in the operating condition, I mean, the PI control that cannot guarantee the desired performance. In those cases, probably you have to go for either, I mean, linear control or even linear with robust. When I say like robust, it actually does consider some uncertainty in the system. Uncertainty is some of the things that we are not sure. And we consider, you know, some like, you know, percentage of variation when you're actually developing that control. And the reason here we are using, because the parameter is changing, that's why we try to use this parameter varying control. So due to this, I mean, variation of the parameter, it also actually changes the controller gain as well. That's how you actually cater the effect of the changes in the mainly here we have considered variation in the stator and rotor resistance, and that is being actually occurred by the changes in the temperature. And we also use some observer because we need to estimate, like, you know, what sort of actually changes that's actually happening in the system, and then we use that one, I mean, with our plant, I mean, to design the control. So again, probably, I mean, it doesn't make sense to go very details in the mathematics because many of you might not be from that electrical and physics and mathematics background. But here again, I mean, as I said previously, that we have some states. So these are the states here we have got. These are the like signal that, I mean, we again, these are the state, and these are the control signal that here we have considered. So after actually doing some this mathematical formulation, we got like the matrix that I mentioned previously. And after that, I mean, we developed that, I mean, LPV control that you can see is here. So here again, I mean, this is your induction machine where we actually measuring like the voltage as well as current, and also we are measuring that angle theta as well, and from that we are converting from, like, you know, ABC to alpha beta frame, and then using that we are using some sort of estimation, both speed and flux, and we are using some reference input based on our experience that this is the speed that we would like to operate. And then we have got speed and flux controller, which is produces the reference for this two LPV control, which is at the end actually just producing beta and alpha component of the voltage of the voltage as an output of this two control. And then again, this is again everything is doing that through PWM. So here again, see that this is the inverter, that's your battery. This is like your induction machine. And then you have got transmission and EV. The LPV controller is seated here. After this, driver commands. And again, this is like a closed loop control. And then we actually tested the performance of this controller using both simulation as well as experiment. We also compare the performance with some other existing control which is available in the literature, and one of them is like a sliding mode control. And also we tested using the testing pattern that EV speed that's actually recommended by the European Council. So you use that trend, and here you can see that it actually closely follow that given command speed. And here again, as I mentioned, you can see we compare with the conventional, and here you can see that R1 actually provide better performance, like in all of the cases where we have shown that the variation for a different performance. But here you can see that even with two different temperature, here we consider 25 degrees centigrade, and here you can see that in two temperature difference, there is a although it's not clear, but if you zoom out, there is a oscillation coming here. So that means it is not giving the desired performance. We also do implement in the lab as well, and even the lab result also shows that it actually provides the desired command that is actually recommended by the European Council. So probably just another 4 or 5 minutes. I'll just quickly go a few more slides, then I'll stop. So on top of that, some of that, vehicle also, you will see they use that modern speed control, and here, some of that electric vehicle, they are using that microprocessor based control. So again, same like that, there are some measured signal that is coming from motor, for example, here speed sensing. There are some temperature and current coming from that sensor as well. And then from the battery, we have got the voltage sensing. And with all that input, the microprocessor, it is actually processing all the signal and producing that control output for that PD amplifier, and then the outcome of the PD amplifier at the end is coming to the main power converter to control the power, which is actually connected with the grid. So this sort of also commercial speed control, that is also available in the market from, different manufacturer. Here I've just shown two, but there are many in the market. And again, here also control coming from PWM, as I mentioned, like that. Mainly when you're controlling, we are just controlling the pulse width. And here you can see that, when you're changing the pulse width, the average motor voltage also changing. And that's how, you are getting different sort of performance. Because again, we don't want to run the vehicle either too low or too high voltage, because that will damage the motor as well as other component in the EV. Same for current. We would like to limit the current within a certain range, temperature as well as speed, because if all of them is good outside the limit, it will have negative impact on the performance as well as the lifetime of the electric vehicles. So probably with that, I'll stop here. So we have got another 10 minutes. So if you have got like any question, comments or suggestion, please feel free to share with us.
Yeah, are there any questions?
Hello, sir. Myself, Ronak Naik.
Yeah.
Sir, basically, you shown in your previous project when there is a changing load, there is a distortion in the current signal. So this is the when there is a change in load, then at that of time, the electric vehicle is supplying the current to compensate the main grid current signal.
You're
Or
right. If it is already sinusoidal, or is not distorted, it will not do anything. But only when there is a distorted and the power quality issue, then the converter will identify it, and then it will the controller will react to resolve that issue. But in the normal time, there is no point. You can use your inverter capacity just for your real and reactive power support. So initially we use fixed amount of for active and reactive, but at the end we also found some even a better control algorithm that's actually automatically calculate and then adjust this capacity depending on the requirement in the system, what sort of capacity will be going for real active power application, and what sort of capacity might go for solving other reactive and power quality issues. So you're right. It will only use when there is a problem in the system.
okay, sir. Thank you, sir.
Any other question?
And also some feedback, whether the way that I'm going, is it you think that right way, or if you have got any feedback that you might like to let me know, that might help me to readjust in coming lecture, and that's how probably all of us can be mutually benefited.
I think the speed is just right, sir.
Thank you. So anyone from here, either you are already doing research on electric vehicle, or you are thinking to work on electric vehicles. It might be any area of electric vehicles, because as I say, there could be number of area you can work on. One is the charging side, the control side, the electric machine drive circuit side. Other could be the mechanical side as well. Also, it could be that the system level, like impact studied as well. On the system level also, there are many things, I mean, you can do, like in the optimization and using artificial intelligence, or even like for voltage stability, frequency stability, solving many of this problem as well.
Yes, sir. This is Chellamal from SRM Institute of Science and Technology, Chennai. I have been working in these areas, sir.
Okay,
Mainly
that's,
on the
yeah, that's good to know.
area
This is
number.
this is like a very exciting area.
Yes.
And as you know that this time also, like there were like few attempts previously as well, but at the end, it didn't, I mean, get the electricity, I mean, EV market. But this time, we are almost sure that, I mean, market will get bigger and bigger.
Yes, sir.
And that's why, I mean, there would be so many issues and challenges. So this is definitely an exciting area, and there are so many projects going on in Australia, in other countries as well.
Actually, I have been working on the power electronics side, sir.
Okay.
We have been acquainted with each other already. I will discuss with you in private chat, actually.
No, definitely. I mean, I will be happy to, you know.
Yes, sir. Actually, we know each other already.
Okay.
That because I'm not able to reveal in this forum, I will do that
No,
in the
yeah,
private chat, sir.
yeah, that makes sense.
I'm working in this area. Mainly, I joined this GIAN course to know about the role of multi-objective optimization in EV applications. Though I'm a power electronic engineer, I'm working only in the power electronic side. I just want to gather knowledge on multi-objective optimization. Mainly
Yeah,
for
I mean,
that, I took this.
probably, you know, in one of the lecture, probably, you know, we probably could focus on that multi-objective optimization. That might be next week. So it might be, you know, different application, but it could be applied to, you know, any application.
Yes. Thank you, sir.
Yes, please.
So I just have one question to ask.
Yeah.
Sir, do you think geomagnetically induced currents would have any effect on the charging process of EVs?
Well, that's I think that's again like a good question. And I myself have not, you know, analyzed its impact, but I saw that, I mean, some people, I mean, they are trying to see that impact, but I think still that area might need, you know, further research just to, I mean, validate that, you know, what sort of actually impact you know, it might be having. But that's a good question, and from my knowledge, I believe that, you know, it needs further investigation.
Right, sir.
Well, that's so. I mean, if there is no any further question and comments, I'll leave it here.
Yes, sir. We can.
Okay, thanks everyone for joining this session, and I look forward to meet you tomorrow again. Thank you. Have a great night. Thank you.
Thank you.
Yeah, good night, sir.
Thank you,
Okay.
sir.
Bye.
Thank you, sir.